All right, welcome back, guys. On today's video, we're going to be talking about distinguishing if a given relation is a function and kind of addressing different ways that questions like this may pop up. We're going to touch on set notation, some function mapping, and then graphing. Okay? All right, so the key thing that you want to look out for to determine if the given question is a function for these three topics is for repeating x values or input values, right? So you'll see that all three of these examples are showing that if there's a repeated input or x value, it's not a function. So that's the key thing. So let's dive in. So let's say you're presented with set notation and you're given what's below right here. Let me bring it up a little bit further up so it's more center on your screen. Okay, so let's say you're given something like this, right? And you're given four coordinates and you're told to determine if this is a function or not. Well, what I would do is look to see if any of my x values are repeating. I have a 0, a 1, 2, and a 3. None of my x values are repeating. Therefore, I can determine that this is a function. So if your x values are repeating, it is not a function. Okay, so let's look at the second example. We have 1, 2, 3, 4, 5 coordinates. A 1, 2, a 5, 3, a 7, 4, a 1, 8, and a 10, 3. Well, right off the bat, if I focus on just my x values, I see that there's a repeating x value, which tells me that this set of coordinates would not be a function. That's the only catch for set notation when looking for a function. Okay? All right, let's try a different category of problems. Mapping. So with mapping, it's the same concept that you're looking for repeating x values. It's just presented to you in a different format. So let's take a look. So in the first one, this is what we would call a one-to-one mapping, right? One-to-one mapping, because each term in your first set maps to one term in your second set. And notice, if this is your x and this is your y, so this is your input, this is your output, all of your x values uniquely go to a output or a y value. 1 goes to A, 2 goes to B, 3 goes to C, and 4 goes to D. So in this situation, we can confidently say this is a function. Let's look at the second example. Let's look at example B. Well, notice that the first input or x value goes to both the value our output 2 and 4. So right off the bat, you can see that the x value is repeating, because if this were represented in a coordinate system like above, you would have 1, 2 and 1, 4. And then you'd have 2, 3, and so on, right? So right off the bat, we see that our x value repeats here. So we can determine that this is not a function. Not a function. So that's pretty much what you're looking for when dealing with the mapping functions in terms of determining if something is a function or not. Okay, and then the last example under this topic would be, let's say, graphing. For graphing, it's a little bit different. What you'd want to look for, or the test to determine if something is a function or not, is the vertical line test. And the vertical line test says that if you were to draw a vertical line on your function at any point, it should only touch that graph once, at one unique point. If it touches at two distinguished points, or two repeating points, I should say, then that determines that your function is not a function, or your given graph is not a function. So let's look at this as an example. So my vertical line test, I would draw a vertical line anywhere along this graph, and you can already tell that it only touches the graph at one unique point. So this we can confidently say is a function. A circle, on the other hand, your x value, so let's say this was -3 on the x-axis, right? X and y. And let's say this was, I don't know, 3, and this was -3. Well, what this is saying is that your x value of -3 here has two repeating values. Your coordinates would be one that is -3, comma, -3, right? -3 on the x and -3 on the y. And then another -3 right here and 3 on the y. -3 on the x, 3 on the y. Two repeating values of x. So this graph of a circle fails the vertical line test, because when you draw a line on your Cartesian coordinate or on your plane, it touches the graph that you're given in two spots along that same vertical line. So therefore we would say not a function. Okay, hopefully this was somewhat helpful. Take a look at the video, pause, stop, try to repeat the video yourself and try to redo some of these questions just to practice, or look online for some other practice problems. But this kind of summarizes identifying if something's a function or not at a basic comprehensible level. Let me know if you have any questions, drop it in the comments, and I'll see if I can get around to it as quickly as possible. If there's other questions you want me to do, just drop that in the comments. All right, thanks.